All right, so we started looking at the exponential functions last lesson. We're going to look at them a little more closely. A couple things you should notice here. An exponential function is any function that is written in the form y equals a to the power x, but a has to be positive. Okay, think about that for a second. If you have y equals, say, negative 2 to the power x, can you picture what this would even look like? Because as x changes from an odd or an even value, it will change this from positive to negative. And so, I mean, I don't know, would the graph look something like this? And you couldn't connect it because they weren't actually continuous. Okay, so this is a bit of a strange one. A has to be a positive constant. Okay, it cannot ever be negative. It also can't be to the power, it can't be 0. Okay, now if you think back to the graphs we did yesterday, some of them went like this, some of them went like this. What was the difference? What caused the graphs to do that? Well, it has to do with the value of a. When a was bigger than 1, if you remember yesterday, the graph looked like this. This was always 1, and there was always this asymptote at y equals 0. Okay, if a was between 0 and 1. I think we had an example where it was 1/3. I think we had an example where it was 1/2 or 1/4. Alright, then the graph went like this. Again through 1, and again with the horizontal asymptote at y equals 0. Okay, so that's something to keep in mind. Generally speaking, when you're doing these graphs, you should remember that. Okay, and yesterday we talked about the direction. When a is greater than 1, we call that an increasing function. Okay, and when it's between 0 and 1, it's decreasing. And the reason for that is we always read left to right, so this graph is getting bigger while this graph is getting smaller. Okay, the graph has a y-intercept of 1, you've seen that. The graph approaches the x-axis, so it has a horizontal asymptote at y equals 0. Okay, the graph does not have an x-intercept unless we do some transformations. We will have some that have an x-intercept. Okay, the domain negative infinity to infinity, the range is 0 to infinity. We saw that yesterday. Alright, so what we're going to do now is this. Now you can see all those values, k, c, d, h. We've used other values. I think we used a, b, c, d when we were doing the sine and cos function. Okay, but the letters don't mean anything. It's what they do that's important. What does the k value do? If we're gonna, sometimes this negative k could be a positive k over there. Alright, what does that do? That affects the vertical translation, in other words, moves it up or down. Okay, what does the c do? Well, that's going to be your vertical stretch or compression. Okay, now the d and the h, they're attached to the x, so they affect the x. The d will be a horizontal stretch or compression, and the h will be a horizontal translation. Okay, so let's try a graph here. Start by doing the basic graph. The basic graph is y equals 3 to the power x. So I'm going to go with a y-intercept of 1, and then if x is 1, I get this. Okay, so I like to start by doing the basic graph, and then I'm going to do the transformations. Okay, what are the transformations? Well, there's a negative in front. What does that do? What would that do to the graph? Well, that's outside. It's not attached to the x, right? It's attached to the y. So it's going to be a vertical flip. So this 1 becomes negative 1. And 1, 3 becomes 1, negative 3. And so this graph will look like this. Okay. Then, what does this plus 1 do? Well, that's going to affect the horizontal. And if you remember, this will be sort of the opposite behavior. So this is actually going to be left 1. So we're going to move this point left 1, and we're going to move this one left 1. Okay, the asymptote won't change. It's still going to be at y equals 0. But this one will become -1, -1, and this will become just -3. Okay, and so the graph would look something like that. Okay, is this an increasing function or decreasing function? It's decreasing. What are the x-intercept? The y-intercept is at -3. The x-intercept, there are none. Equations of the asymptotes, y equals 0. The domain, -infinity to infinity. And the range, I noticed this on some of your tests. Some of you wrote from 0 to -infinity. Right, we always go least to greatest, so -infinity to 0. Okay? Why don't you try that one? Start by doing the basic graph. Then, your next step, let's do y plus 1 equals 2 to the power x. What does that plus 1 do? That's going to be down 1. And then do y plus 1 equals 2 to the power x minus 2. What's this minus 2 going to do? Well, that's going to move it right 2. Now you can probably do this and this at the same time, so maybe we'll try that. Okay, since they're both just translations. Okay, so this is down 1, and this is right 2. Okay, try that. Okay, so we'll start with the basic graph. Okay, and now we're going to go down 1 and right 2. So this y-intercept, down 1, right 2. That's going to be at 2. This point, if I go down 1, right 2, it will be at 3, 1. Okay, and then if I'm going to move the horizontal asymptote down 1 as well, it will now be at y is -1. Okay, and so you should be able to draw, whoops, that's not very good. Should be able to draw that graph something like that. And that would be great, except for one thing. You do need to figure out what the y-intercept is, because that's not obvious. How do you find the y-intercept? You make x be 0. Okay, so we're going to go y plus 1 equals 2 to the power of 0 minus 2. So y plus 1 equals, what's 2 to the -2? That's 1/4. So y equals, if we take away a 1 now, you get -3/4. Okay, there it is. Done. Is this an increasing or decreasing function? It is an increasing function. What are the intercepts? Y-intercept is -3/4. X is 2. Equations of the asymptote, y is -1. The domain, -infinity to infinity. Range, be careful, -1 to infinity this time. Okay. Let's try another one. What's the basic graph here? Y equals 2 to the power x. That should be a no-brainer. 1, 1, 2. Okay, so take a look at the transformations. What has happened to this graph? Well, we could do a vertical stretch. Okay, A vertical stretch means we're going to multiply all the y values by 3. So this would become 3, and this would become 1, 6. What if I multiply the horizontal asymptote by 3? Well, 0 times 3 is still 0. So this graph will look something like that. Okay, and then a little tricky here. We've done that part. We want now to do that negative. Well, you got to factor out the negative, and you're left with x minus 2. Okay, remember that you always have to have whatever that b value or whatever letter you want to call that, that always has to be factored out. What does that negative do? Well, that's a horizontal flip. So that will stay the same. This one will go to negative 1, 6. Okay, and so you'll have this. Okay, now I only have these 2 points. I don't really know where that is, but that's why I like not using a grid, because I'm not going to predict where that is. Okay, and then we have one more graph to do. And that's going to be... Oh, we didn't do this part of it. We're now going to move it right 2. Okay, so move it right 2. If I move this right 2, it goes right on that point, 1, 6. If I move this one right 2, it's going to go to 2, 3. Okay, so my graph will look something like that. Okay. And there's no new x-intercept, but there will be a y-intercept now that we don't know. So let's figure that out. Y equals 3 times 2 to the power of 0 minus 2. This is y equals 3 times 2 to the power of 2, which is 3 times 4. So y is 12. Okay. This is a decreasing function. No x-intercept. Y-intercept is 12. Equations of the asymptotes. Y equals 0. Domain is negative infinity, and the range 0 to infinity. Okay, last question is a word problem, and it gives you a description here. For every meter below the surface of the water, the light intensity is reduced. So this makes sense. As you get further in the water, there's less light. And it's modeled by this equation. Now this should actually look familiar to you. It might not in this form. But when I see this, here's what I'm thinking. I'm thinking y equals 100 times 0.975 to the power of x. This is an exponential function. All right, and if you notice, a is less than 1. So this is a decreasing exponential function. Without even doing much thinking, I know this graph is going to be like this. Okay, now there's a couple things you should know here. D is the depth. All right, the depth. Now you can't have a negative depth. Well, you're thinking, okay, yeah, if we go down, that is negative. But if you think about this, 1 meter below the surface, 2 meters below the surface, etc., etc., you wouldn't have negative 1 meters below the surface. So the graph actually does not exist here. Okay, So let's see if we can figure out some of this stuff. What would the y-intercept be? Well, the y-intercept would be when, well, I guess we better use p, when d is 0. So this will just be 100 times 1, which makes sense. If we're at the surface, when the depth is 0, 100% of the light is possible to see. Makes sense. Okay? So there's our graph. You know that it's going to approach y equals 0. Let's see what the question says. Graph the function for between 0 and 40. Okay, so let's figure out 40. How would you figure that value out? When d is 40, you would go p equals 100 times 0.975 to the power of 40. It's going to be a small number. We don't need to figure that out right now. You can see it's small. It's approaching 0. Okay, so that was for part A. Part B, to the nearest percent, how much light remains at a depth of 10? Okay, at a depth of 10. Well, again, you're going to go 100 times 0.975 to the power of 10. Could figure that out. Okay? But here's one I want you to notice. Look at C. To the nearest meter, what is the depth when only 50% of the light remains? At 50% light, that's the p-value. So you're going to get 50 equals 100 times 0.975 to the power of d. What is d? How in the world are we going to figure out an exponent? Well, this is where you need logarithms. Okay, and that's where we're going to be headed in the next couple of lessons. Okay, not right away, but in a few lessons. Okay, so homework. You can do page 349, numbers 3 to 13. Okay? Good luck with that.